Okay, this is the Chapter 8 review. Chapter 8 is dealing with polygons, specifically quadrilaterals for the most part. But let's take a look on page 501. This is the section 8.1, and it's finding interior angles of polygons. So I'm just going to draw some polygon up here. It doesn't have to be regular for this to be true, but the sum of all the interior angles. So here's all the interior angles, all right? And these we're going to say are all different. So that one and that one and that one, all these around have different measures. Now you might find some of them that have the same thing, but they don't have to, all right? So this is a hexagon. It's got 6 sides. So we're talking about the sum of all interior angles here. And that formula, we said, was n minus 2 times 180, where the n is the number of sides, all right? The number of sides of the polygon. Well, this particular polygon has 6 sides. It's a hexagon. So where do we get this formula from? Well, if you take a vertex here, and I'll just pick this upper left one, and you start drawing diagonals. There's one. Come from this bottom, and then here's another one. How many triangles are there? Well, it's n minus 2. It's 6 minus 2 times 180, because the sum of the angles in each triangle we already know is 180. So we got 4 of them, all right? And that's what you can do every time. So the sum of a 6-sided polygon is going to be 6 minus 2 times 180, or 4 times 180, which is 720 degrees. Well, what if we have a polygon, but we want the exterior angles? Well, exterior angles, we take one at a time. So here's one, and I'll try to come here like that. Got another hexagon, but now we're talking about the exterior angles. Again, these are not all the same, because this is not a regular hexagon. So these angles that I'm drawing, that's 1, got 2, they don't have to be the same. They might be, but they don't have to be. All right. What's the sum of all the exterior angles of any polygon? Well, the sum of the exterior is always 360. Now, if you remember in class, we had that little GeoGebra demonstration where I took the polygon and I just kept zooming out, zoom, 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 zoom out, and then it just, all those sides came to one single point. And so what happened with all the angles going around, well, you go around in a circle, you get 360. So that's the sum of all the exterior and the sum of all the interior angles. And that is that was section 1. Sections 2 and 3 were where we first hit parallelograms, special types of quadrilaterals. We said that there were 5 ways to prove that a quadrilateral is a parallelogram. So let me get this up there. 5 ways. Well, the first way is just looking at both pair of opposite sides. We said number 1, if both pair of opposite sides are parallel. Well, that's from the definition. All right. A quadrilateral with both pair of opposite sides being parallel, that is a parallelogram. Well, then the second one. Well, if both pair of opposite sides are congruent. If you look at both pair of opposite sides and they're congruent, well, then that's also a way of saying that it has to be not just a quadrilateral, but a parallelogram. And then the third one, we get to use a whole lot more of these little ditto marks. If both pair of opposite, well, not just sides, but angles are congruent. If both pair of opposite angles are congruent, then that quadrilateral has to be a parallelogram. The fourth one that we had from this set was the diagonals. If the diagonals bisect each other, so if the diagonals bisect each other, that quadrilateral is a parallelogram. And then the last one was if consecutive angles, in other words, not skipping any, if consecutive angles are supplementary. So these are the 5 ways to show that a quadrilateral is not just a quadrilateral, but it's a special type. It's a parallelogram. Both pair of opposite sides can be parallel. That's the definition. Both pair of opposite sides congruent. Both pair of opposite angles congruent. If the diagonals of this quadrilateral, if they bisect each other, and if consecutive angles are supplementary. Now, that's actually almost exactly the same thing as 3, because see, we don't really need the ifs here in this one. We don't need the ifs. We can get rid of those. If you know that you have a parallelogram, you don't need the if. These 5 properties occur. It's the next section where you don't know that you've got a quadrilateral, you don't know that you have a parallelogram, but you want to show that it is. Well, it's got 5 ways, and it's almost exactly the same. In fact, I'm just going to put the ifs back in. If, and if. The first 4 are proving quadrilateral to be a parallelogram with the if that happens. But the last one doesn't work. So here's where we have to change it and say, if this quadrilateral, let's see, it can't just be the consecutive angles. So we have a different one. If one pair of opposite sides is both parallel and congruent. If you can show that one pair of opposite sides is both parallel and congruent, then the other pair of sides is also going to be parallel and congruent. So if you know you've got a parallelogram, both pair of opposite sides parallel, both pair of opposite sides congruent, both pair of opposite angles congruent, diagonals bisect each other, and consecutive angles are supplementary. If you want to show that it has to be a parallelogram, then you got to find both pair of opposite sides. You've got these right here. But you have to change the last one to where it's one pair of opposite sides, both parallel and congruent. And that's sections 2 and 3. All right. Well, if you look at section 4, it's taking special parallelograms. Well, the special parallelograms are rectangles and rhombuses. So we have 2 different types of parallelograms, rectangles and rhombuses. Well, rectangles have some special properties. They've got the original 5 properties, but they also have a couple of others. The first one, diagonals are congruent. All right. If you have a rectangle specifically, it still has those 5 previous properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, consecutive angles are supplementary, but diagonals are congruent. This is the only parallelogram that has that property. These 2 diagonals here, same length, right? They have exactly the same length. We also know that all of the angles in a rectangle are congruent because they're all right angles. So all angles congruent. All right? So those are some special properties. They don't apply to all quadrilaterals or all parallelograms, but they do for rectangles. Well, let's take a look at a rhombus. A rhombus, let's go ahead and draw one real quick. Rhombus is just a four-sided parallelogram with all of its sides congruent. Again, on this one we said it's an equilateral quadrilateral. Equilateral, quadrilateral, because that rhymes, but it's an equilateral parallelogram. All right? All four sides have to be exactly the same length. On this one, you still have the other properties for parallelograms, but you have a couple of special ones here. Take a look at this diagonal. This diagonal is bisecting these two congruent angles. So the diagonals, both of them, bisect the angles they hit. Or let's say they touch. So is this one. Right? These two angles here, congruent. These two angles here, congruent. They've been bisected, but it's also got a third one. Look at these two diagonals together, and what angle do they form? Well, they're perpendicular. So the diagonals are perpendicular. All right? So these are some special properties for rhombuses and rectangles. But then, what is the most special parallelogram of all? It's a rhombus that is a rectangle. And what do we call a rhombus that's a rectangle? A square. A square is both of them. It has both of these properties of rectangles. It has all three of these for rhombuses. It's got them all. All right? It includes the 5 properties for parallelograms. So this one actually has 10 that we can look at. And those were the special quadrilaterals that were parallelograms. We also have some special quadrilaterals that are not parallelograms, and that's in section 5. These are trapezoids and kites. Let's take a look at the trapezoids first. A trapezoid is sort of looks like a triangle, but one of its sides has been cut off. You just had the top cut off. Now this is just a regular trapezoid. Okay? It has one pair of opposite sides parallel. Doesn't have 2 pair. That would be a parallelogram. Right? So it's a quadrilateral with one pair of opposite sides parallel. Well, that's in general. If you look at this trapezoid, it's not a special trapezoid, right? But we do have special trapezoids, and those are isosceles trapezoids. These are the ones that we study more because they have more special properties. Well, here is an isosceles trapezoid. Instead of just being a triangle that's been cut off, it's an isosceles triangle, which means the 2 base angles here are congruent. But now you've got another base. You got the top. And so these 2 base angles are equal to each other. All right? So specifically, we have both pair of, if you take this pair of opposite angles here and this pair of opposite angles, those are always going to be supplementary. So opposite angles are supplementary every time. Well, what else is special about an isosceles trapezoid? Let me take these little arrows out now. This is the other quadrilateral that has diagonals that are congruent. So in this case, those two blue lines, those diagonals, are congruent. It's not true for all trapezoids. It's only for isosceles trapezoids, right? So that's some other properties that we have here. And isosceles trapezoids are very, very, they just come up a whole lot. Now, for any trapezoid, whether it's isosceles or regular, if we go through and we take the midpoint of one side and the midpoint of the other, and these are the legs, not the bases. So let's say those two segments are the same length, these two are the same length. If we connect the midpoint of one leg to the midpoint of the other, this is called the midsegment. And the midsegment has a special property. It's the average of the two bases. If you take this top base and this bottom base here, the midsegment, its length, is just going to be top plus bottom divided by 2. It's the average. It's halfway between. All right? So if you're given the two bases, you can determine what this midsegment length is. Right? Very, very easy to do that. Now let's take a look at kites, the other non-parallelogram but special quadrilateral. Let me draw one up here. It's also got two pair of congruent sides, but they are not opposite to each other. So in this case, these two bottom segments, these longer ones, those are congruent, but so are these two top ones. All right? So let's take a look at some properties. Well, diagonals. Diagonals are always a big part of it. The long diagonal here. Long diagonal is bisecting the angles that it hits. All right? So this top one, whatever it is, and this bottom one, whatever it is, they're not the same. All right? Opposite angles are not congruent on the long diagonal. But opposite angles on the short diagonal. Here's the short diagonal. Opposite angles here are congruent. So I'll mark these. All right, so this entire angle, let me put it in blue. This entire angle here is exactly the same as that one on the other side. The short diagonal hits the two. It doesn't bisect. We're not saying that the top part and the bottom part are the same. We're not. It's just that one is the same as the other. Now, the last part is that the two diagonals are perpendicular. Diagonals are perpendicular, just like they are for a rhombus. So this angle right here is perpendicular, and so that's what it is. And that's the those are the properties of kites that are special. And that was section 5. Now then, section 6, you would think would be something new, but it's not. If you look at it, this is on page 544. It just has all of these quadrilaterals together, and then it's breaking them apart. It's got parallelograms, trapezoids, kites, the specific ones, and then it goes through and has rectangles, rhombus, going to the square, and then the isosceles trapezoid. So section 6 was just a compilation of everything we'd done from sections 2 through 5, and that was chapter 8.